In this video, we're going to talk about sketching rational functions. Now that we've talked about how to find the domain and the range of a rational function, how to solve rational equations and rational inequalities, you can access those videos. Now, how do you sketch rational functions? Okay, let's have an example. If you have a function f of x is equals to, let's say, negative 2 over x squared minus 4. The first thing that you are supposed to do, you have to find out what we call the vertical asymptotes and the horizontal asymptote. In this case, your vertical asymptote will be, you equate your denominator to be equals to 0. So you have x squared minus 4, this is equals to 0. Now you know that negative 4 is just the same as 2 squared, right? Is equals to 4. There it's equals to 0. Then you find the difference of two squares, okay? X minus 2, x plus 2, this is equals to 0, okay? Therefore your x will be equals to, this is x, your x will be equals to 2, then your x will be equals to negative 2. So these will be your vertical asymptotes. Now how do you find the horizontal asymptote? Now as long as the function that we have, as long as we have the denominator having a higher power, like in this case x squared, than the numerator, in this case x to the power 0, okay, you have a power of 0. As long as the denominator has a higher power than the numerator, the horizontal asymptote will always be at y is equals to 0, like that. Okay, now that is very important. Now the vertical asymptotes, we found a 2 and a negative 2. Now let's find the solution set. Okay, so let's find the solution set. What are we going to have? Okay, so I just draw a simple one this side. Let's say we only have two values. So let's say this is the first one, this is the second one, okay? Then for our equations, this one, we only have two equations, and this one, okay? And like that. Okay, so for our equations, we have equations x minus 2 and x plus 2. Now these ones we are multiplying, okay? They were multiplying like that. So we are finding the what? The product, okay? If you want, you can put them like that on top. But we're not going to do that because of space. So just put their product, okay? I'll represent it by p like that. Okay, now what values do we have? We have a 2 and a negative 2. Okay, now which equation gave us a positive 2? Which equation gave us a positive 2? These 2 came from x minus 2, okay? So it came from this equation. So let's solve that. So I'm saying these 2 came from that. So let's solve that. So if we have x minus 2, if we look for a number that is between 2 and negative 2 and replace it in that equation, what are we going to have? Let's say we pick okay, let me put these ones in order, in starting from the smallest one to the biggest one. Okay, let's do that. So this is 2, this will be negative 2, this will be positive 2. Okay, so now that I've changed them, the equation that gave us negative 2, which was the equation that gave us negative 2, it was x plus 1, okay? X plus 2 actually. So what are you going to do? So if you get your x plus 2, let's say this is x plus 2, you get any number that is let's say between -2 and 2. Let's say you get a 1. Okay, if I put a 1 here, 1 plus 2, you realize that you get a positive number. So you this one will give you positive numbers when you're going in this direction. Okay, then when you get a number that is less than, let's say you get a number that is less than -2, a number like -5, you put -5 here, what are you going to have? You have a negative number here, right? So here you have a negative number. Now let's solve the other one. What if you have 2? The equation that gave us 2 was x minus 2. Okay, x minus 2. So we're saying x minus 2. Now if we get any number that is greater than 2, let's say we get 3 minus 2 give us a positive number, right? So we have a positive here. But if we get any number that is less than 2, let's say we get a number, because we're saying x minus 2, if we get a number that is less than, or that is between -2 and 2, let's say 1 minus 2 give us a negative number as well, right? Okay, what if we get a number that is less than -2, let's say -1? Okay, that will just also give us a negative number like that. Okay, so this is what we have. Now let's find the product. So the product will be your negative multiplied by your negative. What are you going to have? You have a positive. Okay, your positive multiplied by your negative, what are you going to have? You're going to have a negative. Your positive multiplied by your positive, you have a positive like that. Okay, so now we can also find the now let's now graph this. How are you now going to graph this you know, inequality or rational function? Okay, so let's say, okay, let's say this, okay, we have got this and we've got that. Okay, then let's show our horizontal asymptotes. Let's say this is -2. This is our vertical asymptote. The other vertical asymptote, we found that it was 2. Okay, so an asymptote, okay, so we're going to represent by dotted line. We don't want anything to touch this line. Okay, these are our vertical asymptotes. Then our horizontal asymptote, we said it is y equals to 0. This is the x-axis, this is the y-axis. On the x-axis, y is equals to 0. So our horizontal asymptote in this case, it will be just the same line. Just that same line. Okay, so now what are we going to have? Now you can see that the product in the first range going this side, let's say this side, in this range or in this area, the product, we had found that it is a positive number. But now they were saying these ones are rational functions, they are dividing, so you're dividing this with a negative on top. So what are you going to have? A negative, right? So you find that your function, meaning it will go in this direction, in the negative. You want those values which are in the negative axis like that. So what are you going to have? So it will move like that, but it will not touch the vertical asymptote like that. Okay, and like that. This is how it's going to move. Then from this region, from this region, we found that it was a negative, right? So this negative would divide with the negative, okay? That would just be a positive. To just be a positive. So what do we want? So we're going to move in the positive. So we'll move from here and we'll proceed, but we're not supposed to touch the horizontal asymptote. So we'll move until again we go there, approaching this asymptote. So this will be our region, okay, because that's positive. Then in the last region we have a positive. Now this positive will divide with the negative. You just get a negative, right? So in this case we are going down, okay? So you are moving from here, going this side and that side, like that. Okay, so this will be our graph. Okay, now there's a turning point here. So this turning point, I cannot find the turning point because we're not really interested in the turning point. So let's say these ones are you're going to this is negative infinity, this is this is negative infinity, okay, this is positive infinity, like that. So now what will be the domain and the range of this function? Yes, you can find it manually like we used to do, but you can also just use the graph. Now from the graph you're able to see that okay, let me just wrap this just to show the domain and the range. Okay, so the domain for this function will just be equals to, want all the values from negative infinity to negative 2. Negative 2 is a horizontal asymptote, so meaning we're not going to a vertical asymptote, so we're not going to include it. Union negative 2 and is going to 2. 2 is also our vertical asymptote. Union again, you're going to 2. Now you're going to positive infinity, like that. Your range in this case, you're able to see that this graph is moving this direction. So what will be your range? Your range in this case, it's starting from negative infinity, but we are saying the horizontal asymptote is equals to y is equals to 0, right? So in this case you are ending at 0, okay? When you reach 0, you're not crossing, okay, like that. Union, the turning point, you pass here at the turning point, okay, the turning point, you can just differentiate that, find the turning point, then you're going to positive infinity, like that, okay, positive infinity. So that will be the range of this function. Let's have another question. What if you have they've given you to find to sketch the function f of x is equals to x minus 1 over x squared, let's say minus 4. Okay, what are you going to have? Again, to find your vertical asymptote, you're going to equate this expression, the denominator, to be equals to 0. So now this is a quadratic, okay? X squared minus 4 is equals to 0, okay? So what are you going to have? We're saying x, this is a difference of 2 squares. Again, x plus 2 is equals to 0. So you're saying x is equals to 2. Again, you're saying x is equals to negative 2. Okay. Then for the horizontal asymptote, in this case, what are you going to have? The power of x in the denominator is greater than the power of x in the numerator, okay? This is 1, this is 2. So as long as there's that condition, what are you going to have? Your horizontal asymptote will be at y is equals to 0, okay? So now for our vertical asymptotes, let's draw our diagram. So what I will find our solution set. So we have this, we have that, we have that. Okay, let's do that. Okay, make them small. Okay, now what are we going to have? Now for our equations, because we're drawing the diagram, we're also going to draw for this one, x minus 1. So let's just equate also that one to 0. So x minus 1 will be equals to 0. So x will be equals to positive 1. Okay, so the equations that we have, we have the one that we're just from finding, x minus 1, then we have x minus 2, we also have x plus 2. Now these ones we are multiplying and they are dividing with this one that is on top. Okay, so in this case we're trying to find the what, the quotient or the product. Okay, let me just put a p like that to indicate that. Then the lowest value that we have is what? The lowest value in this case we have negative 2, we have a 1, and we have a 2. Okay, now let's determine our solution set. So what are we going to have? If we which equation gave us a negative 2? Okay, the equation that gave us a negative 2 is x plus 2, the one on top. Okay, so let's just solve that. So we're saying x plus 2. Now if we get any number that is greater than negative 2, let's say we get a number between negative 2 and 1, let's say we get 0. So 0 plus 2, you realize that you get a positive number. So here this one will be positive, going this side. If you get a number that is between negative 2 and 1, let's say we get even just like yeah, all of them will give you positives this side. But now if you get a number that is less than negative 2, let's say you get negative 5, because it's negative 5 plus 2, you realize that you have a negative number, so this will be a negative here. Okay, so now let's solve the other one. Let's solve for 1. Which equation gave us 1? 1 came from x minus 1. Okay, so we are saying x minus 1. If we get any number that is, you know, less than 1, or let's say less than 1, let's say 0 minus 1 to give us a negative number, right? So in this case this here will be, we're saying we're going to get a negative number, so this will be a negative. So any number that you're going to get, even this one will be a negative. But if we get a number that is greater than 1, let's say a number like 2, or just 2 itself. So if we say 2 minus 1, that will just give us a positive. So this will be positive and this one will be positive. Okay, now let's solve for 2. Now 2, which equation gave us a 2? The equation that gave us a 2 was x minus 2. Okay, so let's just solve that. So what are we going to have? We have x minus 2. So if we get any number that is greater than 2, let's say a 3 minus 2, this will give us a positive number, right? So this region will give us positive numbers. But now let's say if you get a number that is less than 2, let's say you're getting maybe let me say 1. If I get 1 here, 1 minus 2 give me a negative number, so all the numbers this side will give me negatives. Okay, so now what will be our our product. So our product, when you multiply a negative, a negative, and a negative, what are you going to have? You're going to have a negative. Okay, when you multiply a positive, a negative, and a negative, what are you going to have? You just have a positive. Okay, when you multiply a positive, a negative, and a negative, what are you going to have? You have a negative. Positives, when you multiply all of them, they'll give you a positive number like that. Okay, so those are the values that we have on yeah, for the solution set. So now let's draw our diagram. So let's say our diagram in this case, let's draw here. Okay, okay, let me just erase this part. Okay, good. Now you know that this is your y, this is your x. Okay, so how now are we going to draw that? Let's first represent our vertical asymptotes. The vertical asymptotes that we have, we had -2 and a 2 this side. Okay, then let's show them. So I'll show them like that. Okay, then the horizontal asymptote, we said it is y is equals to 0, which is just the x-axis, which is just this x-axis. So this is y is equals to 0, the x-axis. So we're going to show that as well. Okay, that. This is the y is equals to 0, our horizontal asymptote. Okay, now what other thing do we have? Okay, I think we have enough. So what now are we going to do? Let's look at the first region, this one. Okay, now in the first region we found that our product was a negative, and the power here, because we're dividing, is just positive. So it means that whatever we'll be getting, we'll just be doing with that. Okay, if you have a negative, it's just a negative. If you have a positive, you have a positive. The previous one we had the negative, that's why we had to be dividing here and there, but this one is a positive, so whatever we'll be having will be just that. Okay, so now we have a negative, so it means it will be down. The values that you want will be down in this region. Then let's come to the next region. Okay, because we also had the 1, we want this one. Okay, so let's put our 1 here. Okay, so now the region between -2 and 1, -2 and 1, what did we have? We had a positive. Okay, a positive. So it means we're going to move from here, going in the positive direction, approaching this asymptote like that. So move like that, approaching this asymptote like that. Then in this region, from 1 to 2, what did we have? We had the negative, so meaning it will go down. Okay, so this will go down like that. Then from 2 going this side, what did we have? We had a positive a positive product like that. So what are we going to have? So it means it will be on top, but approaching, this asymptote like that. Okay, so this is our diagram, but now we've noticed that the graph here, we're cutting the y-axis here, so we also have to find that point. Okay, we have to find the y-intercept. On the y-intercept, x is equals to 0. Okay, x is equals to 0. So if you do f of 0 is equals to, wherever there is x, you are placing 0, so it will be just 0 minus 1 over 0 squared minus 4. That will just be, you know, on top we just have a negative 1 over 4, okay, over negative 4. So you just have 1 over 4. So in this case, this point here, where it's cutting the y-axis is yeah, it's 0, 0, 0, 0, 1 over 4. Okay, that point there. Then what other thing can we show on this graph? Okay, I think that's all. Now, how do you show the domain and the range for this one? Okay, so the domain for this function will be, you are seeing that we're coming from the negatives. We're coming from the negatives and we're going to the positives like that. Okay, so the domain from this case will be it will be, you are starting from you know, negative infinity, and you are going to negative 2. Now negative 2 there, right? Then you're going to unite union negative 2, comma 2. Okay, that whole range there. Then you're going to say, yeah, union 2 going to positive infinity like that, throughout like that. Then for your range of the range of this function will be you're moving from negative infinity, okay, negative infinity, and you're going all the way to positive infinity like that. Okay, so from negative infinity to positive infinity like that. So this is how we show this one. Let's solve another one. Well, if you are taught to sketch f of x is equals to 1 over x squared plus 4. Okay, so your vertical, you have to find your vertical asymptote and your horizontal asymptote. Then your horizontal asymptote, you know that you look at the powers of x. You know the powers of x. On your denominator you have a 2, here you just have a 0, so the power of x on the denominator is greater, so therefore your horizontal asymptote is just at y is equals to 0. Then your vertical asymptote, you are equating these two to 0, so x squared plus 4 will be equals to 0. Okay, so x squared is equals to 4. Okay, then you're going to square root, so the square root of that, the square root of that. So therefore your x will just be a positive or equals to, okay, when your 4 went to this side, became a negative, so this is negative. Now the square root of a negative number, the square root of a negative number, the square root of negative 4, x is equals to let's say positive or minus 2i, right? Now this is not a real number, therefore we don't have any vertical asymptote for this function. Okay, so if we don't have the vertical asymptotes, let's try to come up with a table of values just to see how our graph will behave. Okay, we are saying let's say the highest value of x is let's start at 0. So at 0, when you replace in the function, in this function, when you put 0 everywhere, what are you going to get? You realize that you have 1 over 4. Then since this is a quadratic, this x, whether you put a negative or a positive, you still get the same answer, right? So let's say you have, what if you put a positive or negative 1? What are you going to have? If you say 1 over 1 squared, that is just 1 plus 4, right? You have 1 over 5, right? So this will just give us 1 over 5. Whether the 1 is a negative or a positive, when you square it will just give you a 1 there. Okay, so that, let's say we choose another one. Let's say maybe we also pick 2, but now positive or 2, or positive or negative 2, it will also still the same because it's a quadratic down. So if you say 2 squared or negative 2 squared plus 4, what are you going to get? You're going to get 1 over 2 squared, that is 4. 4 plus that is like 8. Okay, so 1 over 8. Okay, now you're able to see that just the behavior of this function, the function is reducing. Okay, negative 4 is greater than negative 1 over 4 is greater than 1 over 5, which is also greater than 1 over 8. Okay, so let's just try to put this into context. Now, how are we going to draw our graph? So our graph in this case will be if we do like that and we do like that, we do like that, okay, so what are we going to have? Okay, we are saying so now where is the graph itself? Because we don't have any vertical asymptotes, so we have to find maybe the y-intercept. So on the y-intercept, you know, x is equals to 0. F of 0 found that is 1 over 4. So let's say 1 over 4 is here. This is our 1 over 4. This is the highest value of y that you can have. We don't have any vertical asymptote. Then we said it is reducing. So because it is reducing, and the horizontal asymptote in this case, we've said it's at, for the y, we've said it's at y is equals to 0, which is this line, or the x-axis. This is y is equals to 0. So it means the behavior of this function, yes, it will start, this will be the maximum, but it will be reducing. But it won't touch the vertical asymptote. But now it's going both directions, because we've also tried the negative numbers. They are also giving us like that, because if you pick negative 1 here and you pick positive 1 and you pick positive 1 here, they'll still give you the same point if it's this one, it's this one, because on either side, because it's a quadratic like that. Okay, so that it will be how you graph this function like that. Okay, anything? The domain and the range, the domain for this function. Okay, the domain for this function will just be, because we found that it had square numbers, or let me say complex numbers, it will just be all real numbers. Okay, we want all real numbers. In this case, from negative infinity to positive infinity, like that. Then the range for this function will be the lowest value of y is the asymptote itself, this one. Okay, that's the lowest value that you can have, 0. Then the highest value of y that you can have, it's this, because that's where the graph started from. Okay, that's where the graph made a turn from. So the highest value of y that you have is just 1 over 4. Now this is included. Okay, you never include an asymptote, that's why we've put an open there like that. So this will be the range for that one. Let's have another one. What if you are told to sketch f of x, this is equals to negative, let's put a negative this time, negative x squared plus 1 Now let's add a constant. Okay, so for the vertical asymptote, what are you going to do? You're going to equate the denominator to be equals to 0. So you have x squared plus 1, this is equals to 0. So x squared is equals to negative 1. So you realize that you have x is equals to the square root of negative 1, okay? When you square root on both sides. Okay, so you have a scenario where you have x is equals to positive or minus I. The square root of negative 1, that's just I, right? So positive or negative I. Now because we have complex we've got a complex number, therefore we don't have vertical asymptotes. Vertical asymptotes, we don't have them. So now you realize that this 4 that is here, this is the shift in the y direction. Okay, in the y direction. So because it's a shift in the y direction, it shifts the function by that. The horizontal asymptote for this function, we say you look at the powers of x. This is, you have a power of 2, here you have a power of 0. So the denominator has a higher power than the numerator. So it means your y, when that condition is met, your y is equals to 0. But now your y has shifted by 4 units. Okay, so how are you going to draw that? Okay, let's draw a diagram. So if you are going to draw a diagram, let's put it here. Let's say this is our y-axis, this is our y is equals to 0 or x-axis. So what are you now going to have? Let's say the highest value that you can have for y will be what? Let's say our vertical asymptote, we've said it has been shifted 4 units. So because it has shifted 4 units, that's where our vertical asymptote will be. Our horizontal asymptote, that's where it will be. So let's just do that. So this like that, this is 4. Okay, it has been shifted 4 from z. It was supposed to be 0, but now it has been shifted at 4. Okay, now what are we now going to do? We have to see the behavior of this function. If let's say you've got, let's say this is x and this is y. Let's say if you put a 0 there, if you put your 0 in the function everywhere here, so you realize if I put a 0 here, you have 0 plus 1, a negative 1 divided by 1, that is just a negative 1. Negative 1 plus 4, that will give you a positive 3. So when you have 0 here, we are getting a 3. What if we put a 1? If we put a 1 here, you have 1 squared plus 1, that is just a 1, then 1 plus 1, that is 2. So you have half, negative half plus 4. Okay, that will just give you something like when you solve like that and like that, you get a number like 7/2. Now you realize that these numbers are becoming bigger and bigger and bigger. So because they are becoming bigger and bigger, the lowest value that you can have for y, we've said when you start at 0, the lowest value that you can have for y is 3. Okay, so let's indicate our 3 here. Now as you are increasing the numbers, if you put a 1, you are getting 2 values from this side and this side because it's a quadratic. Okay, because it's a quadratic. So what are you going to have? Okay, let's just solve that one. Just to let's say negative 1, if it's 1 squared, that is just 1 1 plus 1, that is that's a 2, plus a 4 like that. Okay, plus a 4 like that. So just to make our work easier, let me 4 will just be the same as 8 over 2, right? Okay, so if you do that, negative 1 plus 8, that will just give us a 7. So that's the 7 over 2 that is there. 7 over 2, when you divide 7 divided by 2, that is like 3.5. Okay, so I'm saying as you are increasing, as you are increasing from 0, which is the lowest number, as you are increasing the numbers, the value of y is increasing is increasing like that. So because it is increasing, so our graph in this case, how is it going to move? It is going to move in both directions because it's a quadratic. So it will move in this direction, but it will not touch the asymptote like that. It will also move in this direction, but it will not touch the asymptote like that. Okay, so this is how you show, this is how you draw this one. But now what will be the domain and the range? So the domain for this function will just be, you want all the values from, as you can see, negative infinity to positive infinity. Okay, everything exists because of we don't have the vertical asymptotes. Okay, then the range for this function will be what? The lowest value of y that you have is what? It's a 3. Okay, then the highest value of y that you have is what? It's approaching the asymptote, which is at 4. Okay, now because it's an asymptote, you are not going to include it, so we'll open like that. Okay, so this is how we solve this one. Okay, let's solve another one. Okay, now how do you sketch, let's say, sketch the function f of x is equals to x over x squared minus x minus 6. Okay, so we have a quadratic expression down. Okay, so what will be our horizontal asymptote? We have to look at the powers of of x. This is greater than that, so it means in this case our horizontal asymptote will be at y is equals to 0, right? Then what about our vertical asymptote? We're going to equate this, our denominator, to be equals to 0. Okay, so what are we going to have? We have x squared minus x minus 6 is equals to 0. I think this one we can solve using the product and the the sum method. If we say the product in this case is the coefficient of x and negative 6, that is just negative 6. Okay, that would be negative 6. Then the sum is, you are just getting that one, which is negative 1. Okay, negative 1. Which two numbers can you the factors in this case, which two numbers can we add? They'll give us a negative 1, but when we multiply them, they'll give us a negative 6. So you can just say negative 3 and 2. If you multiply this, they'll give you a negative 6. Okay, if you add the 2, they'll give you a negative 1. That's what we're talking about. Okay, so in this case, what are we going to have? We're going to say x minus 3 x plus 2, this is equals to 0. Okay, therefore your x is equals to 3 and your x is equals to negative 2. Okay, so for us to create our table of values, we are going to also equate the one that is on top to be equals to 0. So x is equals to 0. So we've got 3 values of x. So now how are we going to draw? Let's draw to find our solution set. So let's say that So is this got 3 values of x, so this and that. Okay, let's say okay, this is our equation 1, equation 2, and our equation 3 there. Okay, so let's write our equations. The first equation that we've chosen is x, right? The one that is on top. Then the next one is what? X minus 3. X minus 3. Then the other one is what? X plus 2. The values of x that we have, the smallest one is what? It's -2. Then we've got 0, and the other one gave us -3. Like it gave us a +3 actually, not a +3. Okay, now which equation gave us a -2? Okay, you realize that x plus 2 is the one that gave us a -2. So let's find out so we're saying x plus 2. If we look, let's look for a numbers that are greater than -2, and we put it there. If we put a 0 here, just be like that, and you'll get a positive number. So in this region, these ones will be positives. So this one will be a positive, this one will be a positive, this one will be a positive. What about if we try a number that is less than -2? Let's say -5. -5 plus 2 will give you a negative number. So this will be a negative here. Okay, you have a negative there. Then let's solve the other one. Let's go to 0 now. Which equation gave us 0? It's just x. Okay, x. If you get numbers greater than 0, you know that all of them are positive, right? So these will be positives. Numbers less than 0, they will just be negative like that. Then which equation gave us 3? It's that x minus 3. So x minus 3, if you get any number that is greater than 3, let's say 4, that will just give you a positive number, right? So there we have a positive. Okay, this one will be a positive. But if you get a number that is less than 3, or let's say the number between 0 and 3, let's say maybe you get 1. If you put 1 here, 1 minus 3, you will realize that you get a negative number, so you have a negative. If you get a number, let's say 0, so it's like these ones, all of them will just give you negatives like that. Okay, now let's find these ones are multiplying and they're dividing with that one. So we're just finding the product and the quotient. So in this case, whichever way you're going to choose, you're going to do it will just be the same thing. Let's say this is our product. So if we multiply all the negatives, this one multiplied by this one multiplied by that one, what are we going to have? We just have a negative like that. Okay, then if we multiply a negative, and a positive, what are we going to have? You just have a positive like that. If we multiply a positive, and a positive, what are you going to have? You're going to have a negative. All the positive values will give you positive values like that. Now what will be our, what can we now do? Okay, so I think we can draw from now. We've got everything that we need. Okay, so if we're going to draw our graph will look something like let's start from here and let's draw like that. Okay, so our vertical asymptotes, we said there was -2 and 3 actually, yeah, and 3. So these are vertical asymptotes. The graph will not touch these lines. Okay. Then what about our horizontal asymptote? We said it is y is equals to 0. Okay, so y is equals to 0 is the x-axis. Okay, this is y and that is x. So what other thing do we need? I think we've shown everything. We just need now to determine where our solutions will be. So we have a positive, we have a positive, a coefficient here. Then here we have a negative. Okay, so because of the positive, whatever we have in this solution will just be like that. Okay, so we'll just be considering it like that, unless if it was a negative like in our first question. So what are we going to have? Because it's negative in this region, negative. Okay, so it will go in the negative direction like that, approaching the asymptote. Then the range between 2 and 0, let's say this is 0. Okay, 2 and 0, the range between 2 and 0, we found that it was a positive. Okay, a positive. So because it's a positive, it will approach, to approach this asymptote like that. Okay, then the range between 0 and 3, what did we find? We find that it was a negative. Okay, so because it was a negative, so it will come like that, approaching the asymptote like that. Then greater than 3, we found that it was a positive, so it will be on the positive side, so it will go like that and approaching the asymptote like that. Okay, so this is how you draw our diagram. But now this diagram has passed through this point. It has passed through our asymptote, our y asymptote there. Now someone would ask, how can it be if the horizontal asymptote is not? So you realize that we can cut the horizontal asymptote at that point 0, 0. In the middle, the horizontal asymptote can be cut. But as it approaches infinity, it can't be cut. Okay, it can't be cut. So that's one of the things that you should look out for. Okay, then how do you find the domain and the range? So the domain and the range for this function, what is it going to be? So that domain, okay, the domain you're just able to see is from domain is just from, okay, like you're moving from negative infinity, you come to negative 2 like that, then again union. From negative 2 you're going to negative 2, you're going to 3. Okay, 3 is not included, union. Then from 3 you're going to positive infinity like that. Okay, then your range, the range for this function, you're able to see that this is negative infinity, so it's going from negative infinity and it's going in the positive y values. Okay, that is positive infinity like that. Okay, so that would be the range for this function. Let's solve the last question. What if we say you have a scenario where you're asked to sketch. Okay, let me try to look for an example where you can try to sketch let's say 2x minus 6 over 2 minus x. Okay, now how are you going to find the vertical asymptotes? Okay, like we've been doing, you equate your denominator to be equals to 0, so 2 minus x is equals to 0, so your x in this case will just be equals to 2 like that. Okay, now your horizontal asymptote, how are you going to find this is your vertical asymptote. How are you going to find your horizontal asymptote? Now the degree of the numerator is equals to the degree of the denominator. If you can see, this has a power of 1 and this has a power of 1. Okay, so we're going to divide by the coefficients of x. Okay, we're going to divide by the coefficient of x. The one that is on top has a 2. Okay, the one that has down, the coefficient of x that has down is just negative, right? So negative 1. So therefore our horizontal asymptote will be at 2. Okay, that is very important to know. Now to draw our table of values, we're also going to equate the one that is on top, this one, we're going to equate it to 0. Okay, so 2x minus 6 is equals to 0. So we're going to have what? X is equals to just be equals to 3, because negative 6, take it that side to be positive 6 divided by 2, that will just give you a positive 3 like that. So if we're going to draw a solution set, what are we going to have? How many values do we have? We've got about 2 values. Okay, so we're going to do that. We're going to do this is that, and that is that. How many equations do we have? We have got 2. Okay, so you just do that. Okay, so what are you going to have? So the first equation that we had is 2 minus x. The second equation that we had was that is 2x minus 6. Is it? Yeah, 2x minus 6. Okay, now what values did these ones give us? Okay, it gives one gave us a 2, the other one gave us a 3. Okay, so what now do we do? If we let's start with which one gave us a 2? It was this equation. Okay, that equation gave us a 2. So we're saying 2 minus x. If we pick two values, if you pick any value that is greater than 2, let's say you pick 2 minus, let's say even just a 3, you are going to get a negative number. So this will give you a negative and this one will give you a negative. But if you pick any number that is less than 2, let's say you pick 1, or let's say you pick 1, 2 minus 1, that would give you a positive number, right? So here you have a positive. Okay, now let's do the other equation. The equation 3, the equation that gave us 3, it is the one that is on top. So it's 2x minus 6. Now if you pick any number that is greater than 3, let's say we pick a 4. So if we get a 2 multiplied by 4 minus 6, that will be 8 minus 6. This is a positive number. Okay, so here we have a positive number. But now let's pick a number that is less than let's say you pick a number that is less than 3. Let's say in this case we pick 2. Let's say we pick a 2. So 2 multiplied by 2 multiplied by 6, that would be a 4 minus 6. So this would just give you a negative number. So these ones on the other side will give you negatives like that. So now what do? Let's find the product and the sum. Okay, or the quotient, whatever you want to do, because these ones are dividing and multiplying. Like these ones are dividing. So what are you going to have? If you multiply or you divide a positive divided by a negative, you just get a negative, right? Okay, so this will be a negative. A negative and a negative will give you what? A positive dividing by a positive divided by a negative. What are you going to have? You have a negative like that. Okay, so this is our diagram. So now what do you do now to let's now do the graph. Let's now sketch our graph. Okay, let's say it starts from here. This is our y-axis, this is our x-axis. Okay, so now what do we do? Let's put our vertical asymptotes. Our vertical asymptote, we only had the one, right? We only had one in this case, we only had two. Then for our horizontal asymptote, we saw that it was, we found that it was -2. Okay, so our horizontal asymptote, okay, let's first indicate for our vertical asymptote. This is our vertical asymptote. Then for our horizontal asymptote, we found that it was -2. Let's put -2 here. Let's put -2 here. Okay, so if we're going to draw also our horizontal asymptote, it will just be that. Okay, now how are we now going to draw to show our solutions? The region between okay, let me just push our horizontal. Okay, even just like that, the region between -2 going this other side, what did we find? From 2, let's put maybe another number. Let's put 3 here, because we also had the 3. Also had the 3 there, so we also had the 3. So in this range from 2 to 3, we found that it is positive. Since this is positive, what are we now going to do? So it will be on top, right? Instead of it being down, it will be on top. So let's just do that. So what are we going to have? So this will move in the positive one. Okay, then on the other side, less than 2, this region, we found that it was a negative. So because it was a negative, it will come from there and it will be going like that, approaching the asymptote. Then it will come, there's an asymptote there, then it goes direct like that. It's going direct like that. Now this is, I'm sure you notice something here. This, it's going like that. It is cutting, this is the y-axis, so it's cutting the y-axis here. So we have to find the y-intercept there. At the y-intercept, x is equals to 0. So if you place 0 everywhere, you're just going to get let's say 2 you're going to get -6 over 2. That will just be a -3. So at this point, this is -3. Okay, or yeah, -3 or 0, -3. Then we've also noticed that this other graph, it has cut the x-axis there. At the x-axis, you know, you equate the whole expression to be 0 and you find your x values like that. Okay, so that is it. Then what do you how do you now find the domain and the range? That will be the last part. Yeah, you can use our actual arithmetics where you do, you know, you do the way we've been doing to find that the domain and the range, because you know that in a fraction you don't have to have a 0. So yeah, you can do that. Yes, or you can use our solution set like that. So from our solution set, you can see that the domain is just from -infinity positive 2 union 2, you're going all the way up to infinity, or you equate this to be equals to 0, but you know that 2 minus x should not be equals to 0, because that's, so your x in this case should not be equals to 2. Okay, so you want all the values but you just don't want 2. That's what we're talking about. That's this when you're expressing it in interval notation like that. Okay, then what will be our range? The range of this function will just be equals to what do you want? You're going to find the inverse of that function. Okay, you're going to make x the subject of the formula, then the answer that you get, that's the one that you determine the range from. But we just use our graph because we've already graphed. We're able to see that we just don't want a negative 2 because that's our asymptote. That's the one that we found. Okay, right? So what are we going to do? We're saying we want all the values from negative infinity, but we don't want a negative 2. Okay, so union negative 2 and the positive infinity. We want all the values unless we just don't want negative 2 like that. So that will be our range. Thank you for watching, and don't forget to subscribe. See you in the next session.